Today we're going to take a close look at ratios and proportions, and there's a lot of different applications for ratios and proportions. That's what we're going to take a look at today. To start off with, we're going to simplify ratios, and one thing I want to do is to keep in mind that we want to keep the units. The units for a little bit are going to be pretty important, so I want to concentrate on these. What we're going to do in these first 6 problems is we're going to basically make sure that we have the same units. If we don't, we want to convert. And secondly, we're just going to simplify the fraction. So since these two units are the same, 7 feet and 14 feet, we can actually compare those two things. But the 7 and 14 are divisible by 7, so we can just convert this to 1 foot over 2 feet. This is a ratio. A ratio is always a comparison of two things, and they don't necessarily cancel like a fraction might. So like if one person gets 1 foot of yarn, the other person might get 2 feet of yarn. If one person gets 7 feet of yarn, the other person might get 14 feet of yarn. That's kind of a silly example, but that might be what works out. And number 3, the first thing we need to do is we need to convert this 10 meters into centimeters. The idea is that 1 meter equals 100 centimeters, so 10 meters would equal 1,000 centimeters. So we'll set this up as 400 centimeters over 1,000 centimeters. So now that we're able to compare the same things here, we know that 400 and 1,000 are both divisible by 200, so we'd have 2 centimeters in comparison to 5 centimeters, and that will be our ratio, our comparison of two things. Sometimes they'll write ratios sort of in this ratio format. So it's just simply 10 feet over 3 yards. We know that there are 3 feet for every yard, so that's just going to be 10 feet over 9 yards. I'm sorry, 9 feet. Since there's no way that you can simplify 10 and 9, we'll just say this is our final answer. It says find the ratio of side lengths in ABC, so the side length in ABC, to the side length in DEF. The idea here is this 2 really means this is where our ratio is going to be. We're going to be comparing the side lengths in ABC to the ratio in the side lengths of DEF. In other words, we will take basically ABC and we'll divide it by DEF. This isn't really a formal math, but this 2 signifies what we're comparing. This thing has to come first, this thing has to come second. So what I'll do is I'll grab some length over here from ABC. I'll grab the same corresponding length over here from DEF, and I'll simplify these. Since they both have centimeters, I can just simplify those to 1 centimeter over 2 centimeters. Number 8 would take a little bit more work. This is in feet, and this is in inches. We probably want to convert everything to inches. And then secondly, we're not just going to work from the left to the right. We always have to work from ABC, which is the second one, to DEF, which is the first one. Next, it says use the number line to find the ratio of the distances. AB is just going to be a distance of 2. I find that by just subtracting the B minus the A, so that's 2 minus 0 is 2. AC would just be 6 minus 0, which is 6. Both of those are divisible by 2, so I get 1/3 as my answer. AE, from A all the way out to E, is going to be 14. From B to C, we take C, which is 6, minus 2, which is 4. Both these numbers are divisible by 2, so we have 7 halves. Next, it says the perimeter and the ratio of the length and width of a rectangle is given. Find the length and the width of the rectangle. Let me work with this bottom one, number 15. I like to look at this in regards to an actual rectangle, so I'll just draw this out. Length always signifies the longer side, so I'm just going to say my length here is going to be like 8x. That makes this side also 8x. My width is going to be the shorter side, so width is going to equal 1x. And this side over here is going to equal 1x. So they're giving me this ratio, length to width of 8 to 1. So this side has to be 8 times longer than this side. The thing is, I don't know that the answer is just going to be necessarily 8 and 1. It could be, 16 and 2. It could be 32 and 4. There could be a lot of different responses. Like x could be a lot of different numbers. So now I need the second piece of information in order to make this make sense. The relationship between these deals with perimeter. So perimeter just means I'm going to add up these sides. So 8x plus 1x plus 8x plus 1x. That has to equal a total of 36 centimeters. So all the way around, if we add those things up, has to equal 36. Well, 8 plus 1 is 9. Plus 9 more should give me 18x. 18x equals 36. When I divide both sides by 18, my x equals 2. The goal is not to find the x, but to find the length and the width. So the idea here is that my length, again, equals 8x, or 8 times 2. or my length equals a total of 16. My units are centimeters. My width is equal to 1x, or just my width equals 2 centimeters. This works out nicely that if I were to add this up, this is 16 plus 2, that's 18, plus 16 plus another 2, then that gives me a total of 36. Same thing works for the other two problems. The measures of the angles of a triangle are in the extended ratio given. An extended ratio, a regular ratio, might be like this. To extend it would mean you're going to add at least one more piece on here. They could keep adding these as long as they want, and this is going to be extended. So 2 would be a regular ratio. Extended means there's going to be more than just 2. Find the measures of the angles of the triangle. So we're not just going to solve for x, we're actually going to substitute that back in. It's really a good idea to read the directions fully to make sure what's going on. So in a triangle, whatever your triangle looks like, just remember that the sum of these interior angles, these three angles, has to add up to 180 degrees. And we have this ratio of the angles. So I might just label this as 1x. This angle is 1x. This angle up here is 2x. Now I realize this triangle is not drawn to scale, but the concept is still there that these are going to represent three angle measures. And the sum of the interior angles, 1x plus 2x, has to equal 180 degrees. In this case, 1 plus 1 plus 2 equals 4x. When I divide both sides by 4, I would get 45. My goal again is not to find x, but it's to find the measures of each of the angles. So one angle is 1x, so that's going to be 45 degrees. The other angle, 1x, which is also 45 degrees. And the last one is 2x, which is just be 90 degrees. So these are the measures of the angles of my triangle. And again, 45 plus 90 does indeed equal 180 degrees. We're going to look at solving proportions. Really quickly, this is like the cross products thing we worked on the other day. When you cross multiply, 2 times x should be equal to 1 times 8. We divide both sides by 2 to solve for x, and x equals 4. Same concept works over here. We'd have 12 times z equals 60. When we divide both sides by 12, z equals 5. In this problem, all we're doing is we're actually solving for the z variable. We're letting, we'll assume that you've been able to set up the proportion correctly. Let's jump into something a little bit more complicated. Sometimes people get mixed up with these. In a similar fashion, we're going to cross multiply. In this case, that's 3 times 8, which is 24. And that's going to equal 6 times the quantity, x minus 3. So that's x minus 3 like so. Remember that you have to distribute. A lot of students will say that this is going to be 6x minus 3, when in reality, it's 18. There's a big difference between 3 and 18. Just make sure that you realize that. To solve for x, we're going to add 18 to both sides. So we'd have 42 equals 6x. When we divide both sides by 6, x equals 7. Same concept will work for these next two. Just remember to distribute. Next part, it says the ratio of the two side lengths of the triangle is given. Solve for the variable. It's kind of written in sort of a ratio format where we can sort of see this as AB over AC is means equals, and then 7 over 8. What I'm going to do then is I'm going to substitute. I know that AB is equal to 14A, so I'll just substitute that in here. That's 14A. AC is 48, and this is going to be 7 over 8. What I'll do is I'll just cross multiply here. Cross multiply. 7 times 48, that's a really big number. That'd be 224 maybe, is equal to 8 times 14. That's also a really big number. I really wish I would have known what these numbers were ahead of time. That way I don't have to delay. What I'm doing right now is I'm pulling out my calculator. I'm hoping it's going to work here. 8 times 14, that gives us 112. Let me check just to make sure that this is right. I don't think that's right. 7 times 48. Oh, that's a much bigger number. That's 336. Good thing I checked that. 336. What I'll do then is I'll just divide both sides by 112. Sorry about that. I kind of wish I would have had my calculator handy. And A just equals 3. Next we have an idea. It says the swimming pool of a rectangular swimming pool is 24 feet long. Again, I'll draw this picture 24 feet long. The length is always the longer side. And 10 feet wide. Write the ratio of the pool's width to its length. And we have to simplify it. So it means I want the width first, and then the length. So how long is the width? Well, the width is 10 feet, and the length is 24 feet. We simplify this. These are both divisible by 2, so we'd have 5 feet over 12 feet, and that looks good to me. I could also see someone writing this as 5 feet to 12 feet. That would also be an acceptable answer. What would not be acceptable is if you wrote it this way. This is not correct, because really we're talking about these are our dimensions. We would have to note that it has to be the width first and the length second. So the class size in a high school where the ratio of seniors to underclassmen, there's going to be a ratio between seniors and underclassmen, is 1 to 5. There are 125 seniors. How many underclassmen are there? So the idea here is this is 1 over 5. The 1 representing the number of seniors, so this is going to be 125 up top, and the U on the bottom might be the number of underclassmen. So I'll cross multiply. That'll be U equals 625. My units for this would just be underclassmen. All right. It says the aspect ratio of a television screen is the ratio of the screen's width to its height. A widescreen TV, so it defines what a widescreen TV has a ratio of 16 to 9. What is the height of a widescreen TV? So it tells us we're going to use a widescreen TV, so we have to use a 16 to 9 business. If the width is 26. Well, I need to go back to this definition, and it does say width over height. So I know that the width has to go up top. If I'm given a width of 26, that means that goes up top. My height has to go on the bottom. What I'll do then is I'll, again, grab this calculator, and I'm going to multiply 16 times h. Then I'm going to multiply the 9 times the 26, and that gives me 234. When I divide both sides by 16, I kind of get a weird number. It's 14.625. Now, some people will just probably write this as 14.6 inches, but the reason this is kind of interesting is because this is actually 14 5/8 inches. And this is probably the way that people in America will actually write this, is 14 5/8 inches, because that's actually how long the TV is. In math class, though, we usually cut this off, and we usually talk about this being just to the nearest tenth is usually what we do. Last question here. It says the television screen has a width of 28 inches and a height of 21 inches. What is the aspect ratio? So again, aspect ratio is always width over height. Our width, it says, is 28 inches. Our height is 21 inches. In this case, both these are divisible by 7. So that would give me 4 over 3, written like this. Or probably, since we're writing this in aspect ratio form, like a 4 to 3 ratio would probably be consistent with the way aspect ratios were written before. We've been using ratios today and proportions in order to solve for different side lengths. Lots of different applications. If you ever have any questions, let me know.